Hi, my name is Adeeb Sherif, and here I'm going to talk about the introduction to lock-in amplifier. So, lock-in amplifier is actually an amplifying device for signals which has raw noise in it. We can remove the noise. So, I'm going to talk a little bit about it. Let's go into it. So, first I'll talk a little about the introduction and stuffs, and then go into details about what the lock-in amplifier is and how does it work, the basic principles and things. Then we'll go into the applications and then the summaries and things. Yeah, so the introduction. So what it actually does is it takes in the signal, it removes the noise and gives back the signal. Just as simple as that. So how is this relevant to us? So as you know, like most of the people know, like signal is there everywhere around us, like most of the places, whether it be measuring sensor data, transmit telecommunication, electrical engineering, like everywhere there is signals. And if you are familiar with dealing with signals and stuff, you know that signals always contains a little bit of noise, sometimes a lot of noise, and that's a bad thing for us. Like who is going to like if someone is taking the data from a spectroscopy or things, if noise is there, that will completely affect your results as things. So it's very important to remove this noise. Hence we use some signal conditioning units and things, and lock-in amplifier is one of those signals conditioning. Like we can use lock-in amplifier inside the signal conditioning. So how does it work? Like basic principle. So lock-in principle user utilizes the phase sensitive detection. Like we'll set some phase, and like according to that only the lock-in amplifier passes the signal. For example, we are setting a reference signal here. So according to the reference signal, we'll get the signal what we want. So let me give an example and explain it to you. Imagine you want a particular signal. You have to give a reference signal such that lock-in amplifier only passes the signal you want and cancels every other signals. So there are many methods to give this reference signals. Look, find out these reference signals. Like that will take too much long if I explain here, but there are some methods. So this is what you give the reference signals, and you can get the only signal which you want, which means you will remove every noise, like almost everything, every noise you can remove in it. So yeah, this is the thing, applications of lock-in amplifiers, signal recovery and noise reduction. As I told you, that's what it does. And like talking about this applied instrumentations, we learned about transducers, right? So in transducers, we took an example of electrical transducer. So what is an electrical transducer? Transducer, I will say, what is a transducer? Transducer converts one form of energy into another. Electrical transducers converts one form of energy into an electrical signal. So we use a sensor to sense that electrical energy, energy form in the beginning. Then we use one signal conditioning unit. Why do we use that? Because like this signal which can contain many kind of noise and things. So we want a clear cut picture of the signal. That's uh, that is without the noise. So we use the signal conditioning unit. Here we can integrate this lock-in amplifier, and we can get a clear cut picture of how the signal is. So that's one of the and technical aspects is the things I already told you, which you have to be careful of, like amplification and filtering, demodulation techniques, and phase adjustment, signal alignments, all those things, because you are doing so many changes to the signal. So after removing the noise, you have to get back the signal. So you have to be careful about the things which you do to the signal, so that you can get back the signal. That's what this is. So advanced features is like all the things you can add to this such that you can remove the noises further. Because sometimes the signal, if the signal which you want is has a frequency f, it can contain its harmonic frequencies also, like 2f, 3f, 4f. That things also we need to remove. So the setup to remove that harmonic rejection is also there. And like you can set up a bandwidth which contains your particular frequency and things, and you can use filters also for that case. So all these things helps you to remove your unwanted signals and keep the only signal which you want. That's basically the lock-in. That's what the lock-in amplifier does. So what is its application? Applications is like, as I already told you, wherever there is signals, like most of the cases you can use this thing, but particularly I will take 2 3 examples and see. Say biomedical and biochemical analysis, as I told you, like any kind of imaging, spectroscopy and things, that data can contain noise. A particular data which contain noise, if you don't know it is a noise, that can lead to a very serious problems. You will write some wrong inferences from that. So it's very important to remove that, especially in that in the case of medical industry, because it can cause serious trouble to the patients also. And in cases of physics also, like especially I'm working in electron spin resonance thing, setting up the lab. So we use this lock-in amplifier because the signal we get is has very small amplitude. So it can contain a lot of amount of noises. So we use this lock-in amplifier to remove those noises, and we can get the results we want. And yeah, this is the thing I wanted to talk. Like it's a little off topic. I'll talk it in 10 15 seconds. It's the thing that I told you. It can be an error, but it can be something great also. Like Jocelyn Bell, she discovered pulsar thinking that it was an error in the beginning. Her reading caused some kind of error which she didn't expect. So later on, it was discovered to be pulsar. So it may be that it's a very great discovery which can lead to Nobel Prize also. Even though she didn't get Nobel Prize, her professor got. Anyways, that's not the thing. It can be a great scientific discovery also, and at the same time there is a risk that it can be something very stupid also. So you need to know whether it's an error or not, it's a noise or not. So you have to be very careful and you have to get the clear cut picture of what you are doing. So this lock-in amplifier can help in this case at all. So yeah, this is the conclusion and things. Precise signal recovery, I have told you, like applications, wherever there is signals you can apply this. Future potential, like as long as much as you get getting a clear picture of the signal, you can get more information about the thing which you want, the thing of interest. You will get clear picture of it. If it is more clear, the more informations you can get from it. So yeah, that's what we use the lock-in amplifier for, and this is it. I conclude. Yeah, thank you.